What steps would need to be taken to prove that figure ABCD is a rhombus? What formulas would you need to use? Don't do the actual work. Alright, so if I want to show something is a rhombus, the first thing I need to do before I can say it's a rhombus is show that it's a parallelogram. In order to show a shape is a parallelogram, it needs to do any of these 5 properties. Because in order to be a rhombus, you must be a parallelogram. So let's just think of something about a parallelogram. Parallelogram has the name parallel in it. So it's easiest to show that your opposite sides are parallel if you want to prove that a shape is a parallelogram. So my first step is I'm going to show the figure is a parallelogram. Meaning, I'm going to show this side, DC, and AB have the same slope. I'm going to show AD and BC have the same slope. Now, why do parallel lines have the same slope? Parallel means that your lines won't intersect. So if both lines are slanted this much, they're not going to intersect. The minute I take one line and I change the slant, they're going to intersect, right? These lines won't intersect, but once this line slants a little bit more in any direction, now they're going to intersect. But if I show that the steepness of both of those pairs of sides are the same, the shape has to be a parallelogram. And I'm going to show this by slope. Now I've showed it's a parallelogram, but that means it could be a rectangle, a rhombus, or a square. So now I want to show something specific to the rhombus. A rhombus has 4 congruent sides. So let's say for step 2, I'm going to show adjacent sides are congruent. And how do I show things are congruent, the same length? That's the distance formula. Now you may be asking, why am I only showing the sides next to each other are equal and not all 4? So let's recall. Let's say this side is 4. I've already proved this shape is a parallelogram, meaning opposite sides have to be equal. Now if I showed that the 2 sides next to each other are 4, those are the adjacent sides. But since I know that this is a parallelogram and that the opposite sides are equal, that would mean these have to be the same, and likewise these have to be the same. So just by showing the 2 sides next to each other are the same length, I've ended up actually showing all 4 sides are congruent. So let's look at this question. I've already plotted the diagram just to save time. Riley plotted A, B, C, and D to form a quadrilateral. Determine what kind of shape Riley has plotted. Use appropriate formulas, distance, midpoint, or slope to support your answer. So already I'm starting off, I don't know what shape this is, okay? Let's start off very general. The best thing to do would be to decide, all right, they already said it's a quadrilateral. From quadrilateral, what's the next specific shape that I can be? I can be a kite if I have no parallel sides. I could be a trapezoid if I have at least 1 pair of parallel sides. And I can be a parallelogram if I have 2 pairs of parallel sides. So the deciding factor between being a kite, a trapezoid, or a parallelogram all deal with parallel sides. So if you have none, you're a kite. If you have 1, you're a trapezoid. If you have 2, you're a trapezoid and a parallelogram. So in order to define what shape, I'm going to figure out which sides are parallel. Now looking at this shape, it should be pretty evident to you which sides are parallel. These sides clearly have the same slope. This side and this side, they're not intersecting anytime soon. But AB and DC, DC's got a pretty intense slant that if this line were to continue, they're going to intersect. But I'm going to back this up with math, and I'm going to illustrate why there is only 1 pair of parallel sides. Now to figure this out, you can use the slope formula, but I typically like to use just counting rise over run where possible, just to make it a little bit less strenuous with the tedious calculations. So if I want the slope from A to B, I'm just going to construct a little triangle from A to B. And I'm going to remember that slope is rise over run. So first I'm going to count how many boxes up do I need to go. I have to go 2 boxes up and 1, 2, 3, 4 boxes over. So my slope is 2 over 4, which simplifies to 1/2. Now, this is going uphill, meaning the slope is positive. Now let's find the slope of the corresponding side, DC. And I'm going to label this, just so it's clear what I found. For the slope of DC, once again, I'm going to construct a triangle. It should already be clear these are not going to come out the same. The rise is 1. The run is 1, 2, 3, 4, 5. DC slope is 1/5. The slopes are not the same, therefore the lines are not parallel. Let's show, though, that there's only one pair of parallel sides. So let's get the slopes of the other set. For AD, I'm going to draw another triangle. Again, to save time, you can construct smaller triangles to wherever there's good points. So I don't need to go all the way from A to D. I could have constructed a smaller triangle. First, I'm going to count the rise. 1, 2, 3, 4, 5, 6 over 2. 6 over 2 simplifies to 3. This line is going downhill, so this slope is negative. Likewise, if I looked at DC, this slope is going downhill, this slope is negative. You want to imagine that if you were walking, you would be going down, versus here if you're walking, you would be going uphill. Now I'm going to look at my slope for BC. I'm going to construct one more triangle. My rise is 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. My line is going downhill, so my slope is negative. These slopes are the same, meaning these lines are parallel. These slopes are different, meaning these lines are not parallel. So I'm going to say, since only one pair of sides are parallel, the shape must be a what? Which shape has only one pair? This is none. This is at least one. This is 2. So it must be a trapezoid. Riley defines an isosceles trapezoid as a trapezoid with congruent diagonals. Use Riley's definition to prove that ABCD is not an isosceles trapezoid. So they're telling you the definition of an isosceles trapezoid is a trapezoid with congruent diagonals. So if you have congruent diagonals, you are an isosceles trapezoid. If you do not have congruent diagonals, you are not an isosceles trapezoid. You must fit this requirement in order to be this shape. So we're going to check that requirement and see if it checks out. If it does, it's an isosceles trapezoid. If not, it's not an isosceles trapezoid. Since they're telling you to prove that it is not, that means your distances of the two are not going to be the same. But let's go through the calculations and prove what it is that they're asking of us. So a diagonal line goes like this. So one diagonal is AC and another diagonal is DB. So let's look at the diagonal AC. A is -1, 6. C is 6 comma negative 1. Our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, the order in which you use these coordinates doesn't matter as long as you are consistent. So if you start with C and then go to A, you must go back to C and then go to A for your next set of coordinates. So I'm going to do 6 minus negative 1 squared plus negative 1 minus 6 squared. Double negative is a plus. So I get 7 squared plus negative 7 squared. Seven times 7 is 49. 49 plus 49. So this is basically 50 plus 50, which is 100. But 49 is 1 less than 50, and 49 is 1 less than 50. So instead of being 100, it's going to be the square root of 98. I could break this down, but there's no need to bother. I'm just trying to show that I get the same distance. Now let's do diagonal BD. BD. B has coordinates of 3, 8. D has coordinates of 1, 0. Again, I'm using the distance formula. x2 minus x1. So 1 minus 3 squared plus 0 minus 8 squared. 1 minus 3, I'm going to have negative 2 squared plus negative 8 squared. Negative 2 squared is 4. Negative 8 squared is 64. Anytime you square a negative, remember it comes out positive. This will be the square root of 68. These distances are different. These are lengths. Since they're not the same, that means that these diagonals are not congruent. And if the diagonals are not congruent, that means it's not an isosceles trapezoid. So I'm going to say since the diagonals are not equal, the shape is not an isosceles trapezoid. As long as you just write about a sentence that can properly sum up what the point of your math was and what it shows, that would be a sufficient explanation. Hopefully this quiz makes better sense. Let me know what you guys think, and be sure to ask any questions.